Probability is a measure of the likelihood of the occurrence of some event whose outcome is unknown. There is a particular vocabulary that goes along with the business of making the calculation of probability. Let's talk about the vocabulary a little bit and then we'll get into some calculations of probability. Probability situations begin with some experiment, and an experiment is just some activity where we can observe the outcome of the activity. For example, tossing a coin, we can observe in tossing the coin whether the coin comes up heads or tails. Rolling a die, we observe the face of the die as it comes up and stops rolling. Drawing a card from a deck of cards. Interviewing voters for their preference on a particular political candidate, perhaps. So all of these are various kinds of experiments. A sample space is a list of all possible outcomes, and generally this list is put into kind of a set format. So it's the set of all possible outcomes for some experiment. An event is one or more outcomes. Now it's starting to sound a little complicated, and I think we take the complication out of it with an example. An experiment is like rolling a die. Now, rolling a die, you know that there are 6 faces on a die. It's just a little cube, and you roll the cube, and 1 or 2 or 3 or 4 or 5 or 6 can come up when the die finishes its rolling process. So the sample space, all the possible outcomes, would be the set consisting of 1, 2, 3, 4, 5, 6. And that's all there is to it. Now, some events associated with this would be rolling a 5. That's an event. You see, rolling an even number, that's an event. Rolling a number less than 3. All of these then are events associated with that experiment. Let's talk about probability. The probability that some event will occur is calculated as favorable outcomes, the number of favorable outcomes over the number of possible outcomes. So, rolling a die, if we want to find the probability that a 5 comes up when we roll, then how many favorable outcomes are there? How many ways are there to roll a 5? Well, there's only one way to roll a 5. There's only one 5, you see. And the number of possible outcomes, well, to find the possible outcomes, you just count the items in the sample space. So there are 6 possible outcomes in rolling a die. So the probability of rolling a 5 is 1 over 6. Now, probability numbers are written as fractions like this, or they could be written as decimals, or the decimals could be turned into percents. So a probability number can be a fraction, a decimal, or a percent. What about the probability that an even number is rolled? Well, let's see. The probability of even means favorable outcomes over possible outcomes. How many even numbers are there in the sample space? You see, that's kind of what we're asking for the numerator of our probability fraction. Well, there's 2, 4, and 6 that are even numbers in the sample space. So there are 3 even numbers out of the 6 possible outcomes. So the probability then is 3 over 6, or 1/2, or 50 hundredths, or 5 tenths, or 50 hundredths, or 50%. All mean the same thing. The probability that the number that we roll is less than 3. Less than 3, that would mean it would have to be 1 or 2. So the favorable outcomes, there are 2 of them, the 1 or the 2. And the possible outcomes is 6. Reducing, we get 1/3 for the probability. What about the probability that we roll a 7? Well, gee, 7 is not even in the sample space, so this is not a possibility. So there are no possible favorable outcomes here. You see, no way to roll a 7, and there are 6 possible outcomes, so 0 over 6 is 0. And the reason I put this example in here is because this is an impossibility, and the probability associated with something which is impossible is 0. Now consider this one. The probability that the number that we roll is a 1-digit number. If we look at the sample space, all of the numbers are 1-digit numbers. So this has to happen. This is a certainty. So there are 6 situations that will fill this out of the 6 possible outcomes. So the probability here is 1. So items which are impossible have a probability of 0 associated with them, and items that are certain have a probability of 1 associated with them. So probability numbers are numbers that are between 0 and 1 generally. consider this situation, tossing a coin, then rolling a die. So we have two things kind of in tandem with one another. We toss the coin, we roll a die. Let's list the sample space first of all. The sample space, all of the possible outcomes for this situation. Well, let's see. We could toss a head and roll a 1. We could toss a head, roll a 2. Toss head, roll 3. Toss head, roll 4. Head 5, head 6. Then we could go through and toss a tail with all of those items on the die. So T1 through T6. So now these are all the possible outcomes for this situation. Now, what about the probability of tossing a head and rolling an odd number? So head and odd. Let's see how many of the items in the sample space would fill this this description. H odd, and let's see, H1 is head odd. H3 and H5, all H odd items. So there are 3 items that would be favorable outcomes out of the total possible outcomes of 12. So 3 over 12, or 1/4, or 0.25, or 25%. How about the probability of a tail and a number greater than 4? Let's underline those. Tail greater than 4. Let's see, here are all the tails. A tail greater than 4, oh, that's just 2 items. So it's 2 out of 12, or 1/6 for the probability. Now, all of the probabilities we've been talking about are called theoretical probabilities because they're based on theory, and the theory is that all of the outcomes in the experiment are equally likely. And we make our calculation according to that probability idea we talked about, the favorable outcomes over the possible outcomes. Now, there's another kind of probability. There's another way to calculate probabilities, or another arena in which probabilities are calculated. And those are empirical probabilities. And I'll give you a couple of examples, but they're based upon observations. If a meteorologist comes on television and says there is a 75% chance of rain tomorrow, then that probability is, now how in the world is that favorable outcomes over possible outcomes? Well, it turns out that here's what the meteorologist is doing. The meteorologist is referring to past events, and given the circumstances that we're going to have in our weather condition tomorrow, you see, from past experience, when those conditions have existed, 75% of the time it has rained. And therefore we can say that we have a 75% chance of rain tomorrow. You see, so we're using past observations in order to make this probability. All right, so that's the idea. Here's another example. Oh, and by the way, the probability then is figured as, instead of favorable outcomes over possible outcomes, it's the observations of a certain event over the number of possible events, of all of the possible observations of the event, you see. Another example, an insurance company, and suppose that there were 2,549 theft claims and 927 of them were for more than $5,000. All right, so that establishes our past experience. The probability that the next theft claim will be for more than $5,000 is what? You see, well, our past experience, our the evidence that we have about this situation is that 927 out of 2,549 were for claims of greater than $5,000. So the probability that the next one will be that way is 927 over 2,549, which turns out to be about 0.36 or 36%.